Hello everyone, welcome to my channel. In this video I am going to discuss a very interesting question. As you can see, the question is displayed in the screen. You may pause this video if you want to give this question a try and keep watching for a solution. Before proceeding in the solution, I would like to clarify the misconceptions that many might have while solving this question. So the first and most common misconception is blindly following the diagram of the question. So the strategies that the question setters use is that they sometimes provide misleading diagrams or wrong diagrams so that the students get wrong answers, and our strategy must be to realize that the diagram is wrong, or to keep in mind that the diagram given in the question might not always be correct. For example, if you see this diagram properly, we want to balance this whole system. So we want to ensure that it does not topple. So many might think that these lanes are given equal. So many assume that the center of gravity will lie along this line of this whole system, and by seeing the data given in the question, many assume that since this length and this length are equal, so they will assume it to be x, and taking the length L they will solve, but we will not get to the answer using that approach. And that is the what I will say strategy that the exam setter or the question setters have used to befool the students. So the system will not be balanced if these lengths are equal. If you observe carefully, the center of mass or the center of gravity of this rod lies somewhere around here, and of this somewhere around here. So already the center of mass or gravity is crossing this line, so it cannot be balanced in this condition. So to solve this question, we have to first draw a correct diagram, or we have to first know what the correct diagram must be. So I'm telling you, first let me proceed by taking one block. If I consider only one block is kept, then we all know that it has to be kept at its center. Means if this whole length is L, then this length must be L by 2. We all know this. And then what if we keep another block? If we keep another block, then the thing that we must know is that we cannot keep the original block at the length of L by 2. Means we have to bring this edge slightly to this side like this, and then we have to keep the block somewhere around here. So what I am doing is that for example, I am explaining the logic behind keeping these two systems. I know that if I want consider this system here, just before toppling, the normal reaction will act in this direction and weight will act in this direction. So to balance the net torques, this length must be equal. That is why it is coming as L by 2, right? But what if I consider this situation? Let me try to think that where I will keep this block so that it does not topple. The thing that we must keep in mind that not only these blocks, means the whole system does not topple, means this block does not topple, this block does not topple, this block does not topple. So all are in rotational equilibrium. All the blocks are individually in rotational equilibrium. So this block will not topple over this block also. So if I ignore this block, means if I consider only this part of the system, see here normal reaction will act in this direction and weight will act in this direction. So I can say that this distance will again be L by 2, but this distance will not be L by 2. This distance will change, and I am coming to that. So if I consider only the top block, I can now still reason that this distance has to be L by 2. Now let me consider what this distance has to be. See that now that I know that this distance is L by 2 and I know that these two blocks will not topple, so the center of mass or the center of gravity must lie along this line, and I want to find this distance. Let me assume it to be x. Now one more very useful theorem that we must know, that the sum of the mass moments about center of mass is 0. So means that is just changing a difference. If I want to calculate center of mass from this line, then I will say that it must lie at a distance like this, then I will subtract that from the length of the rod, but that will be too lengthy. But to reduce our calculations, what we assume is that the sum of mass moments about center of mass is 0. That is, I want to say that mi RIC, it is 0. Now why I am saying that, let me give a quick derivation of that. RIC can be written as RI minus RC. So it is summation mi RI minus RC is constant, it will come out summation mi. Now by definition, RC is defined as summation of mi RI by summation of mi. So this term, if I cross multiply, it is coming as summation of mi into RC minus RC into summation of mi. So you can see that this cancels. So this thing we will use to reduce our calculations. So the center of mass of these two systems must lie at a distance x. So if I consider this block as mass m, both will be of mass m, and I know that the center of mass of this block lies at a distance this. So I can write m into what is this distance x, and that must be equal to this block center of mass. See, this whole distance is L by 2 and this is at a distance x, so it will be L by 2 minus x, sorry, m into L by 2 minus x. If I cancel out the m, I will get that x is equal to L by 4. So this distance is coming out as L by 4 for two block system. Now let me explain that how can we generalize this further. If we want to really create such a situation, that is, we want to balance blocks or bricks like this, what shall we do? The strategy is that first of all we will take two bricks or two blocks, and we will place the topmost block such that its center of mass coincides with this edge. Then what we will do, then we will take this whole system and place it over a third block, and we have to place it in such a way that this whole system remains in equilibrium. And then we will take this whole system and place it over another block so that this entire system remains in equilibrium. So as you can realize that we are proceeding from top to bottom, not from bottom to top. So this diagram is clearly wrong. I have explained it previously only, because the center of mass lie here, it will definitely topple. So the strategy is like this: we have to begin from the top, keep it at the distance such that its center of mass coincide with this edge, and then we have to take these two blocks together, keep it over a third block, then these three keep it over a fourth, and so on. So now let me explain how can we deduce what will be the length for three block systems, or what will be the offset. That is the answer of our question. I will also deduce for four blocks also. So if I consider three blocks, you must have realized by this time now that the first block must be placed quite to the left, means its center of mass must be towards this side, so that I can balance all the moments, right? Then this second block must be somewhere around here, third block must be somewhere, no, third block has to be somewhere around here. So what I have told that since this block will not topple, so this center of mass must lie along this edge, right? So this distance is L by 2. Now I want to know that what will be this distance. Now I know that these two blocks will not topple. So since these two blocks will not topple, their center of mass will lie along this line. So if I want to find this distance, I am naming this as x, and its center of mass is here somewhere. So using the law of mass moments, sum of mass moments is 0. Using that, I can say that this block's mass is m, and its center of mass is at a distance x, and that must be equal to this block's mass is m, and it is at a distance of L by 2 minus x. So x turns out as L by 4. Now I want to know what is this distance. Why? I know that this entire system will not topple, so the center of mass of this entire system lies at this distance, lies along this line. So what I will do is, I will find the center of mass of this whole system. For that, what I have to do is, let me assume these two blocks as a single block, right? I know that these two blocks center of mass lies at this distance because they are not toppling. So that is the edge I have already found that as L by 4. So as per my assumption, the center of mass of these two blocks must lie at this distance, and I know the center of mass of the lower block lies at this distance. Now I can find out y. So y can be given as, if I consider these two blocks as together, so I can write as 2m into, see, from this line it is located at a distance of y, and that is my assumption. I have assumed it to be y, and this block center of mass is m times, see, this whole is L by 2 minus y. Now if I cancel out, see, I am getting 3y equal to L by 2, that implies y equal to L by 6. So the answer to our question is the total length of offset. See, this is L by 2, L by 4, L by 6, L by 2 plus L by 4 plus L by 6, which will give us as 6 plus 3, 9 plus 2, 11, 11 L by 12, and that is option D. Option D is our correct answer. Now let me quickly tell what will be the scenario if I want to balance 4 blocks. How can I reduce the maximum offset? So using the same concept we can do that. See, here is the ground. We have to place the first block quite to the left, then the second block, then the third block, and finally the fourth block. We have to know this total length. So I know that this block is in equilibrium, so this length must be L by 2. That is clearly from observation we can say that for the topmost block this has to be L by 2. Now see this length, I will not use the formula, so I know it will be L by 4, but still I am deriving it just for now. I know that these two blocks will be in equilibrium, so their center of mass must lie along this line. Let me call this distance x. So this mass is m times x equal to this mass is m times L by 2, this distance is L by 2, here its center of mass will be L by 2 minus x. So we can see that x equal to L by 4. Now I want to find this distance y. I know that these three blocks are in equilibrium, so their center of mass must lie along this line, right? And if I now for the time being consider these two blocks as a system, I know their center of mass lies in this line, so I can say that 2m and their center of mass lies along this line, so this distance is y, and this is equal to m, this block's mass is m, and this is L by 2 minus y. So y comes out here as L by 6. And if I want to find this distance, suppose z, then I know that these 4 blocks are in equilibrium, so the center of mass of these 4 blocks must lie along this line. If I consider these 3 blocks as a system, so their mass is 3m, and I know that their center of mass will lie along this line z, and that must be equal to m times L by 2 minus z. So if I transpose this, 4z equal to L by 2, that implies z equal to L by 8. Z equal to L by 8. Now we can sum up all this, L by 2 plus L by 4 plus L by 6 plus L by 8, and then we will get our required answer for 4 blocks. So one thing that you can realize that this follows a harmonic series. See, each term, if we consider the denominator, they have a common ratio, common difference of 2, so the reciprocals are in AP, and if the reciprocals are in arithmetic progression, then their original terms are in harmonic progression, 2, 4, 6, 8. So this entire series is in harmonic progression. Thank you for watching this video.